In this example, a pilot flies 360 miles and then drives 240 miles by car to reach a destination. The plane flies 60 miles per hour faster than the car, and the car ride takes 1 hour longer than the flight. How fast is the car? So let's let x be the speed of the car. Obviously, for this problem, we're assuming that the speed is on average the same the entire time for both the car and the plane. So we do a table which we have the rate, time, and distance. And then we have by the plane and the car. Let's see, for the car, we're letting x be the speed of the car, so that'll be the rate. Now the plane flies 60 miles per hour faster. It's got to go faster than that, I think, to stay in the air, but let's just say that it goes 60 miles per hour faster than the car, so that'll be x plus 60. The distances we do know, so for the plane it was 360 miles, and for the car it was 240 miles. Now the times, we don't know the exact time for them separately. We do know that the car ride takes 1 hour longer than the flight. Well, one thing we do know that rate times time is equal to distance. But that means that time is equal to distance divided by rate. So we can say that the time for the plane was 360 over x plus 60, and the time for the car was 240 over x. Now again, we don't know their exact time separately, but we do know that the car ride takes 1 hour longer than the flight. So that means, so the car ride, which was the time was 240 over x, is 1 hour more than the time for the flight. So that'd be, the time for the flight was 360 over x plus 60, and the time for the car ride was, like I said, 1 hour longer. So we'd add 1 to that. So this would be our equation in this case. Now what we would do next is, to solve this equation, you'd multiply both sides by the LCD, while our denominators are x and x plus 60, so the LCD would be x times x plus 60. So multiplying them both by that, well, let's see, the 240 over x times that LCD, the x's would cancel, so you get 240 times x plus 60. The 360 over the x plus 60, the x plus 60's cancel, so you get 360x. And then the 1 times the LCD would just be that x times x plus 60. So distributing, okay, getting my calculator out. Let's see, so first, distributing that 240, we get the 240x plus, now 240 times 60, that would be 14,400. Then we'd have the 360x and then x squared plus 60x. We'd want to get everything with x on one side, everything else on the other side. We'd also want it so that the x squared, which is the highest power, would be positive. So we're going to move everything to the right-hand side. So we're going to subtract the 240x from both sides. Well, we'd have and put it in order. So we'd have the x squared. Now let's see, we'd have the 360x plus 60x would be 420x. And then minus the 240, that would give us 180x. And then subtracting that 14,400. And then we'd have to factor this. Now these are pretty large numbers, and you could start from the beginning, like you could say, okay, 2 times what gives us the 14,400. And one thing, when you're finding the two numbers, since this is a negative, we know one's positive, one's negative. Since this is 180 is positive, that tells us the larger one must be the positive. So you could do like -1, 14,400, one pair. -2, 14,400 divided by 2 is, so that'd be 7,200. And let's just say if you went down, it'd be like -60, and 240. That's the one we want. Okay, so it'd be x minus 60, x plus 240. The product of those two binomials is equal to 0, so either the x minus 60 is 0, or the x plus 240 is 0. So that gives you x is 60, or x is negative 240. Well, x is the speed of the car, so it's not driving in reverse or anything like that. So anyway, the speed has to be positive. So you say that the car, is going at 60 miles per hour. And if they did ask what would be the speed of the plane, well, it would be x plus 60, so 120 miles per hour.